Hey guys, welcome to my channel. In this tutorial and subsequent tutorial, I'll be teaching you how to build applications powered by large language models. We'll not be diving straight into how to build this application without you understanding, but I'll teach you through flow diagrams, what we are going to build, how it will work, and then finally we'll get our hands dirty using Python and Langchain as a framework in order to build whatever we've discussed from these flow diagrams. Today being the first day, we'll be looking at how to build a simple AI workflow. Let's get right into it. So for every AI workflow, LLM or the large language model is the brain of the organization. And this large language model, you can get it from companies such as OpenAI, Anthropic, and Google. So they give you access through their APIs to be able to communicate with their large language models that they have trained on large or huge amount of data, and they have hosted somewhere in the cloud for you to have access to it. In this particular tutorial series, I'll teach you how to connect to models coming from all these three companies, but for today we'll start with Google. So we'll use models coming from Google. All right. So as I said earlier, the LLM is the brain of the organization, and as a user, what you do is to ask this LLM question. So just as you open Cloud Desktop or OpenAI Desktop or on your phone, and there you just start typing, okay, what is this and this, what is that and that, and the LLM is able to give you an output. But one thing about these LLMs is that they have a knowledge cutoff date. So if you train a large language model on huge amount of data and you deploy it today, it has no idea on informations that we'll be getting from tomorrow. So when you ask it such informations, it will have no idea about it. It's just like opening ChatGPT and asking it, what is the price of my microphone? So it will tell you, I'm not sure which microphone you mean, and is giving you context. So it's asking you to give it more context in order for it to answer you. So that's one characteristic of large language models. And to be able to solve that problem, what you do is to give this large language model context. Okay, so you give them informations about the questions you are going to ask. And in the term of large language model, we call it context. And this context, you can take it from PDF file, text files, or Word document. So you can just get this document and feed this document directly into the large language model, and then when you ask the question, the large language model is going to pull out that particular information and is going to use that information to give you an output, which I'm calling LLM output. Okay, so this is a simple system we are coming to design today, and I'll also give you some of the advantages of this system and some of the flaws you should expect as well, or when you shouldn't use this type of system to solve certain types of problem. So let's get into some of the advantages. So this system is cost efficient. Okay, so you can see, you just ask a question, you give it a context, and then the LLM gives you an output. It's straightforward, and because it's straightforward, it doesn't incur a lot of cost, like compared to AI agents that need to run in the loop using other tools and all of that. This is very simple and it's not going to incur a lot of cost, but there is a catch to that. These systems are easy to debug, so when you get an output which doesn't correlate with the context you provide, then you definitely just need to check, okay, is the context I'm providing to this LLM going through it, and is it using it to give me the right answer? So you can see, you can just easily debug where the problem is coming from because it's not a sophisticated system. Then the next thing is that it's predictable. Yeah, so it's self-explanatory. You give it a question, you know the type of answer it should give you, so you can predict if the LLM is giving you the right answer or not. So it's just straightforward as that. So this is the system we'll be building, but there is a catch to this, and there is a situation where you don't need to use this type of system. And one instance is that when your data, okay, when your context you want to provide is very big, let's say you have huge amount of data, these LLMs have what we call the context window. Okay, they have maximum context window, and that's the amount of data they can take before trying to forget things. So if your data is huge, this will not is not going to be a very good option. Also, if your data is huge and you try to provide it as a context, then you end up paying more because your tokens is calculated on your input questions and your context and the output the LLM is giving you. So since the amount you pay to OpenAI, Anthropic, and Google is dependent on that, you have to make sure the only time you use this system is when the data source you have is not that huge, it's something small. So when it's if it's something small, that means you are not going to pay more, and everything will just work seamlessly. So that is the catch to this particular system. All right, so this is the theory. Now let's get our hands dirty in writing some code and try to solve this particular problem, or let's try to build this particular system. So I've opened VS Code here, and over here I have some data. So I have a TST data, I have a data in a doc format, and I have a data in a PDF format. I'll be teaching you how to read this data using Langchain, all of the formats using Langchain. So what I'll go ahead and do now is to initialize a project. I'll be using UV as my package manager. So what I'll do is to write UV init, and this is going to initialize a project right here. And straight off, I'm going to install the libraries we'll be using. So I'll do UV add, and I'm going to add Langchain. We'll also add Langchain community to get access to the loaders we'll be using to load the files. And I'll also add Langchain, is it google-genai? So let me spell Langchain right. Hyphen google hyphen gen AI. I'll also add Python hyphen dot env to read our env file. I'll also add this particular library, is a docx to TST to be able to read the TST file. It works together with Langchain. And these are the libraries I will need. So let me hit enter on this. If we need any further libraries, I'll let you know. I'll install it and you will get access to it. So we've installed all these libraries. And one thing about UV is about the speed. You can see with PEEP, I'm not sure will be done in this short period of time. So UV will also go ahead and create you the virtual environment and everything that you need by default. So everything just works seamlessly. So the next thing I'll go ahead and do here is to create .env file. So create a file called .env and hit enter. And with this file, you need to get your API key and paste it right here. So I'll call it key and write is equal to. Then just open your browser and go to Google AI Studio. So if you are a first time, I just type Google AI Studio, hit enter on this, click this link, and Google is very generous enough to give us API key. So for free, that you can use for free. So just click on create API key, give it a name. So AI tutorial, and then click on create key, and this is going to create the API key for you. Guys, I'll be deleting this API key after the tutorial, so just go ahead and get your own API key. Don't use mine. So once you create it, come back to .env file and paste it right here. So this is your API key. This is mine. So one thing I also love about UV is that it creates .main file for you automatically. So I'll just get rid of this code right here, and then I'll start importing the libraries that we'll use. So I'll import .env to load our environment key. So from .env, I'm going to import load env, and also from Langchain as called google-genai, we are going to import what we call chat google generative AI. So that will set up our large language model. And what else do we need to import? We need to import OS to read our API key. So import OS. So from here, let's get our API key. So first of all, just type load.env here to load all environmental variables, and then we'll say our API key is equal to os.get env, and over here make sure you type in the name you have given to your API key in the .env file in that particular parenthesis. So I'll just copy this, come here and just paste it here. So this will get my API key for me. And if you are not sure, like I always do, I print this once and I call this API key. So I'll run this once to see if my API key will be printed. Once it's printed and I'm sure I'm reading it, If not, then I know, okay, my API key is not. So you can see I got my API key here, which means I've read it right. So yeah, since we get it, now we can go ahead and set up our AI model. So from the diagram, we have this AI model, which is the brain of the system. So let's set it up. So to set it up, first of all, let's give it a name, and this name we'll call it LLM. And LLM is going to be our chat generative AI. And inside here, just give it your API key, which is equal to your API key, and also the name of the model you'll be using. So we'll be using the gemma model, one of the gemma models. So let me just, the Google models have very weird names. So let me copy this up. The particular model we'll use, they have a lot of weird names. You can check the names on their site or uh in the Google AI Studio. So we'll be using this particular name, Gemma 431B-IT. So this is the model we'll be using. And to make sure that everything is working, or to make sure that this model can give us response when we give it an input, okay, so let's say you give it a user prompt, can this model be able to give us an output? Once the model can give you an output, you are sure you have set up the model right and this model can work. So for that, I'm going to put that in a response variable, and this is equal to our llm dot invoke. So we use the invoke function, and inside this invoke function we can ask it a question. What is AI? Let's just use what is AI in short. And let's print the output. So the output will be an AI message, and in order to get the content, you can just print let's print response dot text, and this is going to give us the content, only the answer. And I'm going ahead to run this to see if our model is set up correctly. So now it's sending requests to Google API, through Google APIs to Google's models, and these Google models are going to respond to our answer. And here we go, guys. So you can see, in short, artificial intelligence technology that allow computers, machines, blah blah blah. So we can now attest that our model is working, and we have been able to set up this model correctly. So once the model is working correctly, the next thing we have to figure out is how to give this model some context, okay, so that we can ask questions that the model have no idea about, or the model is not trained on such data. So let's try to give it some context, and based on the files that you have, you might use one thing or the other. So if you have a PDF file, then you can use this particular thing from Langchain. So we say from Langchain community, from Langchain underscore community dot document loaders. Here is it. We are coming to import. If you have PDF, you can use the PDF reader, PDF loader, sorry. Then if you have document, you can also use the doc to text. So docx to text loader. And then if you have tst files, you have two ways. You can write a custom Python code to read the file, or you can use the tst loader. So you can use the tst loader. So all of this works based on the file that you have. And as you can see, we have different files here, but the loading process is the same. So any of them that you use, you can just load it. So let me go ahead and comment this out, and then I will come down here and I'll call this my data is equal to. So let's try and first load the one in the, maybe the PDF, or the one in the text data. So it's equal to PDF data py-pdf loader, and over here you give it the path to the file you want to load. So let's define our file path or data path. Let's call it data path. And our data path is equal to, the name of the PDF is what, resume.pdf. PDF. So this is the path, and just provide the data path here. So this will now load your data, and what you can now do is that PDFs is equal to data dot load. So this load method is going to load everything for you, and it will return it as a list. So we can first of course print the length of the list. So let's run it and see if we are able to load it correctly. So I'll raise this and let's see if we are able to load everything correctly. So yeah, we got some error. PyPDF package not found. Please install it with. Okay, so let's install that using uv add PyPDF, and let's see. Okay, uv is adding it. Okay, it's added. Let's run our code again. Python, or let's say pymain.py. Hit enter on this and let's see if we are able to load it. So you can see we are now able to load our file from the PDF. So if I open the PDF right here, it's my resume and it contains data about my resume, and you can see we are able to what, load it. So now we can feed this data to the large language model just as we see here, and we can ask it questions based on this data to be able to retrieve information from this data and use this information to answer us the question. So this one way we can do that. Okay, so once we are able to read this data, now most of our heavy lifting is done. So we can collect this and then we can come here and now ask questions, feed it together with the data, and it's going to answer. So I will stop printing this now, save this, and then let's continue in invoking the LLM together with the data. So a simple way to do that is to, so let's just copy this, put it here. Say our response is llm.invoke, and then we can ask question based on this PDF. So let's ask names of projects the resume owner have done. So we are expecting it to list this project. So let's ask that question. So inside there, what I would do is that I will say, let me use fprint. I will say using the context provided, and then over here I'm just going to pass the pdfx directly, list the projects the resume owner have done. So this is the question I'm asking, and then let's see if it's able to list these projects. We'll compare it against what is in the, let me format this well. We'll compare it against what is in the PDF and see if the LLM is able to answer us based on the context we are provided to it. So let's come back here, raise our terminal, save this code, and run main.py. So let's see if it's able to answer us and give us the right answer based on the context we have provided to it. We go. So let's read this. So based on the provided resume, the project the owner has completed are retrieval augmented generation chatbot, nano-learn AI power. So it has described the cancer prediction LLM. And you can see if we open this resume, I lower this up, you can see under project we have retrieval augmented, we have nano-learn, we have cancer prediction, we have. So this is how you can pass in information, or you can give large language model context, and based on that context is going to answer you or give you answers, right? But I'm telling you, in your situation, if the file that you have is so big or too big, then this approach will work, but it will consume a lot of it. It will cost you more. So we have better approaches which we call RAG, retrieval augmented generation, and I will be teaching you how to build that. I already have tutorials on that, but I'll be making updated tutorial on how to do that using the Langchain framework together with the Python programming language. But if you want a way to do this, then this is how simple it is for you to implement something like this, just by passing the information together with your questions to the large language model for it to answer you based on your question. Okay, so we've looked at how to read PDF files, but in case you have a Word document, is the same approach. So for Word, you can just use maybe let's call it data underscore Word, and data underscore Word will be the same as you using the Word doc to Word reader. So the doc to Word loader, and here you just give it the same data path, the same approach, and all you do is what data Word dot load. So it's the same approach. You just do this, and let's call this Word underscore data. So now you can pass in this Word data in place of PDF. So this is how you read the Word data as well. If you want to read TST, it's the same thing. You do TST loader. Here you pass in the data path, and then TST loader dot load, and you get the data. So these are the ways you can read all, and this code will be on my GitHub where you guys are going to get access to it. So you can just take it and then use it as you want. Okay, so feel free, the code will be on GitHub, and in the final code I'm going to read the word and also comment everything up for you guys. So in the final code you have a readme which will be updated. You have main.py file which every line of code will be commented, and you can use it as you want. So guys, this is how you can build what we've learned about. You can give LLM context and ask questions based on that context and get an output. If you love this tutorial, let me know in the comment section, share it with someone, and most importantly, don't forget to subscribe and leave your questions in the comment section. Thanks for watching once again, and I'll see you in the next one.